Okay, buckle up, settle in, get yourself some water, a coffee, whatever will get you through these next 9 problems. But this one's going to be most likely a relatively long one. So question number 1, parabolas. So parabolas have shapes, and those shapes look like this or this. And this is all determined by its a value. When a is less than 0 or a negative number, we're going to get the upside down parabola. When a is greater than 0, we're going to get a right side up parabola. That's one of the most important concepts. The next thing is that we're going to have 3 different types of forms. We're going to have standard form, we're going to have vertex form, and we're going to have x-intercept form. And we're going to do 3 problems in each of those forms. And each form has a template. The template for standard form looks like this. And you see that a value that we were talking about. That's going to be the coefficient of x squared. So the first thing I should always do is list out my a values, my b value. My a is 1, my b is 2, and my c in this example is 3. That's ugly. Good. Once I have that, the first thing I'm going to find when it's in standard form is the axis of symmetry. I won't always find the axis of symmetry first, but when I'm provided the equation in standard form, and I know it because it mirrors this template, I'm going to find the axis of symmetry first. And the axis of symmetry utilizes this equation. X equals the opposite of b over 2a. So I'm looking at my b value, which is 2, and I'm going to find the opposite of my b value over 2 times my a value, which gives me negative 2 over 2, which equals negative 1. That equation simplifies to x equals negative 1. So how do we draw that? Well, where does x equal negative 1? Along here. And this is my axis of symmetry. This is where all the points will reflect across. And more importantly is the second step. We're going to find the vertex. The vertex is either the minimum or the maximum. When it is a U, this is going to be the minimum point. When it's an upside down U, it's going to be a max point. So this is a maximum point. This is a minimum point because it's the bottom of the graph. When it's upside down, it's the tallest, it's the highest point. So finding the vertex, we're going to take this x value and we're going to plug in x equals negative 1 into the equation. Here's my starting equation. So when I plug it in, I'm going to get, oops, sorry, I already wrote that wrong. I'm plugging in a negative 1 and I'm squaring it. I'm plugging in a negative 1 and I'm multiplying it by 2. So I'm going to do the exponent. Negative 1 quantity squared is 1. 2 times negative 1 is negative 2. Plus 3 gives me negative 1 plus 3, which is 2. So when I plugged in negative 1, I got a positive 2 as my value. So this is my vertex. So I'm going to go and graph that. Negative 1, 2. Negative 1, positive 2. Negative 1, positive 2. Now, the third thing is I'm going to find something that is relatively easy. I'm going to find my y-intercept. There's 2 ways we can find it. One is we know in all x or all y-intercepts, the x value will be 0. So we could plug it back into the formula and find out what y is. But even easier, we know that the y-intercept is always going to be my c value in standard form. So my c value is 3, so my y-intercept is equal to 3. So I'm going to go on the y-axis. I'm going to make a dot at 3. So I had 0, 3. Now I'm going to reflect it. So I see that this point is 1 away from the axis of symmetry. So its reflection point is going to be 1 away also. So that would be that location. Okay, so I'm going to take all this little nonsense. Ooh, I can't take all of it away. What am I going to do? I'm going to do that. And then I'm going to get my eraser out and I'm going to get that. Make that look a little bit better. And now I'm going to move it back. And now I'm going to put my points. There we go. So I have 0, 3. Its reflection point is going to be -2, 3. That's this location right here. That's that coordinate, shall we say. So now I have 3 points. So the next thing, 4, is mirror the y-intercept. Oh, y-intercept, yeah. 0, 3 is my y-intercept. If I mirror it, I got -2, 3. I think that was its mirror point. -2, 3 was the mirror point. And then step 5 is find the 4th point. I have 3. I'm going to find the 4th. And I have to pick another x value. What x values have I used? -2, -1, and 0. So I'm going to use 1. I'm going to plug into the equation when x equals 1. So I'm going to plug in 1 squared plus 2 times 1 plus 3 gives me 1 plus 2 plus 3 gives me 3 plus 3 gives me 6. So when I plugged in 1, I got 6. That's going to be my 4th point. So 1, 6 is here. Let's label it. And it's 2 away, so I'm going to move 2 in the opposite direction. That location is -3, 6. That's based upon this y value. That was so bad. All right, let's erase it. Good. So now I have 5 points. Once I have 5 points, I can graph all of the solutions. This line represents all the solutions to this equation y equals x squared plus 2x plus 3. So 5 and 6 is mirror the 4th point. So mirroring the 4th point, I think it ended up, what was it, -4, 6? -3, 6. -3, 6 was the mirror. Good. All right. That's pretty straightforward. Standard is pretty good. So first thing, let's label our A, B, and C. A is 3. B is 0, because B is the coefficient of x. I don't see an x in here. I have an x squared, but I don't have an x. And my C value, my constant, is -4. So the first thing is axis of symmetry. X equals the opposite of B over 2A. The opposite of B, my B value was 0. 2 times 3 is 6. 0 over 6 equals 0. So my axis of symmetry is where x equals 0. So if I have to find my vertex, I'm going to plug in x equals 0 into the equation y equals 3x squared minus 4. So let's plug in 0 for x. Now important here, this is multiplication, this is an exponent. We're always going to do the exponent first. 0 squared is 0. Now we're going to do the multiplication. 3 times 0 is 0, minus 4 is -4. So my vertex is going to be 0, -4. 0, -4. That takes me here. Let's put the location. Good. Now the next thing is to find the y-intercept. But, hello, what do we notice? The y-intercept is going to lie on the y-axis. Guess what else lied on the y-axis? My vertex. So in this instance, which is special and unique, is a case where my vertex also ended up being my y-intercept. Is my vertex. So I don't get a free second point, and I also don't get to reflect it because it lies on the axis of symmetry. So in this specific example, I actually have to find my second point by plugging in an x value. The only x value we've used is 0. So I need to pick another x value. I'll pick 1. Let's keep it simple. We have 3x squared minus y. Y equals 3 times 1 quantity squared minus 4. Again, we have multiplication and exponents. What do I do first? I'm going to do that exponent first. So I'm going to do 1 squared. 1 squared is 1. Now I'm going to do the multiplication part. 3 times 1 is 3, minus 4 is negative 1. So when I plugged in 1, I got negative 1. This is my second point. So I got 1, negative 1. I think that's what it was. All right, 1, negative 1, 1, negative 1. 1, negative 1. Let's mirror it. It should be there. That gives me negative 1, negative 1. Now I have 3 points, so part 5 is find a fourth point. Let's pick another x. I'm going to pick x equals 2. Y equals 3x squared minus 4. Plugging in 2. 3 times 2 squared minus 4. 3 times 4 minus 4. 12 minus 4. Y equals 8. So when I plugged in 2, I got 8 as my fourth point. What is it? 2, 8. 2, 8, way up here. 2, 8, let's mirror it. The mirror is negative 2, 8. And I have 5 points now. I have 5 points. I've labeled my 5 points. I'm sketching all the solutions with arrows. And that would be your answer. Now, one thing that we need to point out is the commonality of what your solutions and what my solutions are. We're all not going to pick the same x, but the things that we all need to have is everybody has to have the vertex labeled. Everybody has to have the y-intercept labeled. And now, everything other than that can be up to you. Okay? It'll be easy if you mirror the y-intercept when you can, and it'll be easy if you pick points relatively close to the vertex. But that'll be up to you. Number 3, the difficult part of this is a is a fraction. So my a value is 1/3. My b value is negative 4. And my c value is 9. Let's find the axis of symmetry. Axis of symmetry is opposite of b over 2a. Opposite of b over 2 times a. 1/3. So the opposite of negative 4 is positive 4. And 2 times 1/3 is 2/3. So we're left with 4 divided by 2/3, which mathematically I can rewrite. Instead of writing it vertically, I can write it horizontally, because this division bar convert to this form of division. Here's my numerator divided by my denominator. Now we don't have division, so we're going to convert that division to multiplication by taking the reciprocal of that fraction, which is 3 over 2. Now this 2 is in the denominator, this 4 is in the numerator. They can cancel, and then we multiply numerator times numerator, and we get 6. So the axis of symmetry is 6. That's a new one. We haven't done that in all of our practice problems. And we know what lies on the axis of symmetry? The vertex. So we're going to find the vertex by plugging in 6 into the equation. Y equals, let's look at that equation, 1/3 x squared, I think it's minus 4x plus 9. So we're going to plug in 6 for x. So 1/3 6 squared minus 4 times 6 plus 9. We're going to square 6 first, which is 36. Negative 4 times 6 is negative 24. 3 is in the denominator, cancels with 36 is 12. So we get 12 minus 24 plus 9. Y equals negative 12 plus 9. Y equals negative 3. So when I plugged in 6, I got negative 3. This is going to be my vertex. 6, negative 3, 6, negative 3 is located right here. My A is positive, so I know it's going to be a U. So 6, negative 3. All right, next one should be the y-intercept. Everybody should have the y-intercept. Y-intercept, remember, is my C value. My C value equals 9, so my y-intercept equals 9. That's a horrible 9. 9. 0, 9 is my y-intercept. Let's go to the graph. 0, 9 is right here. 0, 9. It is 6 away. So I'm going to make a dot on my page somewhere relatively close. And I went 6 from that point. So I'm going to go 6 this way. And I'm at 6, so 6 plus 6 takes me to 12, 9. That's going to be my point. Okay, that's how we calculated that. It's a nice, easy way to calculate it. So I have 3 points, and now I'm going to find my 4th point. 4 was mirror. 5 is 4th point. I'm going to pick an x. What x values are available? 0 I've used, and 6. Now, I can do 1, but understand it's going to be in this area here. I can also do one that is closer to the vertex. So I could do 5 or 4. But let's also keep in mind that we've got this fraction. So whatever I plug in for x is going to have to multiply by 1/3. So I kind of want this value, after I'm squaring it, to be a multiple of 3. So why don't we just choose 3? Let's choose 3 as my x. That's going to be a whole lot easier. So when we have y equals 1/3 x squared minus 4x plus 9, I think that was the formula. When we plug in 3 for x, you get this as your equation, and 3 squared is 9, and 1/3 times 9 gives me 3, so I have 3 minus 12 plus 9, and we get negative 9 and positive 9. What? Equals 0. So when I plugged in 3, I got 0 as my 4th point. Didn't do that on purpose, but that's kind of cool. So 3, 0. Love it. That is 1, 2, 3 away, 1, 2, 3 away. So I'm going to go 1, 2, 3 in the other direction. So this is the point 3, 0, and this is going to be the point 9, 0. I have 5 points now, albeit very crazy and on the paper, but those work quite nicely. So that is standard form. if you're only being assessed on standard form, you can stop now and it'll be fine. But if you're being assessed on vertex form also, then keep going. And x-intercept also, stay with me. Number 4 deals with vertex. The vertex form, the template, is y equals a times the quantity, x minus h quantity squared plus k. A still tells me whether it goes up or down, and my vertex is going to utilize the h and the k, alphabetical order. And the only thing we have to be aware of here, a real challenge, is the difference between negative h and positive h. So when we look at that h value, we're really seeing the opposite of my graphing h value. So when I see this, I see the opposite of what it really is. So when I want to find the vertex, which is the first step, and it's a freebie, my vertex is going to be the opposite of what I see in h, and then my k value, which is straight up. So my vertex for number 4 is going to be -6, -1. Now, we got that for free. Notice my a value is -2. So I know that it's going to go upside down. So I'm going to label my point above it, because this is going to be my max point, -6, -1. And now I also know, since this is my vertex, that the axis of symmetry lies on every single vertex, no matter what format. Next thing, I just drew my axis of symmetry. Do you know what that equation looks like if we wanted to ask for it? X equals -6. Very good. Now we're going to find the y-intercept. The y-intercept, there is no c, there is no shortcut here. We have to utilize that we know that the y-intercept, my x value, is going to be 0. So we're going to plug it into this equation. We're going to plug in 0 for x. We get -2 times 0 plus 6 quantity squared minus 1. -2 times 6 squared minus 1. All we did was we simplified this. That was my next step. I have to simplify inside the parentheses before I do my exponent. And now we're going to do the exponent before multiplication. So we're going to square 6, not yellow. We're going to square 6, -2 times 36 minus 1. Oh, goodness. Oh, -72 minus 1, y equals -73. How cuckoo is that point that we have to graph? 0, -73. Oh, goodness. That's going to go right here. 0, -73. Now, it is 6 away from the axis of symmetry. So we're going to move 6 in this direction on that same horizontal value of -73. What is my location, though? What is my coordinate on that mirror point? Well, that's going to be -12, -73. That's going to be the mirror point. Those are going to be some extreme. And you have to, because I told you, everybody has to have a y-intercept. On the assessment, I'll do a better job of finding something a little bit closer. Sorry. 4th point now. Let's pick something close. Let's pick an x value close to the vertex. How about -4? I like that. -4 looks kind of nice. Or even -5, but we'll do -4 just for kicks and giggles. I think that is x minus 6 minus 1. Oh, plus 6 minus 1. Plus 6 minus 1. Is that correct? Let me make sure. Yep, plus 6 minus 1, -2. Awesome. We plug in -4 for my x, quantity squared, sorry. we're going to do negative 2, 2 squared minus 1. We're going to do negative 2 times 4 minus 1. I did not. I should have gone right next to it. Negative 8 minus 1. Y equals negative 9. So we plugged in a negative 4 and we got a negative 9. Negative 4, negative 9 is right here. Negative 4, negative 9. That works with the shape, 2 away. So this will give me negative 8, negative 9. And that, it's upside down. And I knew that because my A was negative 2. And it's not going to be the most beautiful parabola because negative 73 is way, way down there. But those points all should work. Okay? So that's our first vertex. Let's do our next vertex. Let's see if it'll be a little bit more genteel. My vertex is going to be the opposite of what I see. I see a positive 3, so my x value is negative 3. And then it's going to be my k value, which is negative 1. Negative 3, negative 1 is here. My A is 1, so I'm going to label it under because I know it's going to be a U. My axis of symmetry is going to lie on the vertex. Axis of symmetry is going to be x equals negative 3. Negative 3. I'm going to do my y-intercept by plugging in 0 in for x. Y equals 0 plus 3 quantity squared minus 1, which equals 3 squared minus 1, which equals 9 minus 1, which equals 8. So 0, 8 is my y-intercept. 0, 8. That is 3 away. 1, 2, 3 away. And that took me to negative 6, 8. And I'm going to pick a point, an x value close to my vertex. So I'm going to take negative 2. Negative 2. So fourth point, x equals negative 2. Y equals negative 2 plus 3 quantity squared minus 1. That gives me 1 squared minus 1. That gives me 1 minus 1. That gives me 0. So when I plugged in negative 2, I got 0. Negative 2, 0. Oh, I like that. Negative 2, comma 0. And then mirror it. Takes me to negative 4, 0. I've got 5 points, and I can graph it. Boom. Last one. I see my h value, or the opposite of my h value. Where's my k value? Well, it's right there, invisible. So my vertex, that's the tricky part of this one. My vertex, oh, also my A is negative 1/2, so I know my parabola is going to be upside down. So my vertex is going to be negative 5, 0. Negative 5, 0 is right there. It's going to be upside down, so I'll write this above it. My axis of symmetry is going to be on negative 5. My y-intercept, x equals 0. Let's see what we do here. Negative 1/2. 0 plus 5 quantity squared. I don't have to write this because that's invisible. We don't have to rewrite that because it's kind of silly. Which is 5 squared. Negative 1/2 times 25, which is easy. That's negative 25 halves, which equals negative 12 and 1/2. So when I plugged in 0, I got negative 12 and 1/2. That's down here. 0 for x, negative 12 and 1/2. That is 5 away from the axis of symmetry, so I'm going to go 5 in the other way. And that's going to take me to negative 10. I'll write it inside, negative 10 on my x, negative 12.5 on my y. Now we got to find the fourth point. Again, notice that my a is a fraction. I'm going to have to multiply by 1/2 after squaring this. So I'm going to pick a value that's going to pop out a multiple of 2. So I don't want to do 1 because 1's going to be here and it's going to be way down. Can I do 4? 4? No. Let's do negative 3. Watch what happens when we do negative 3. That's a real good. Advanced students, fourth point. X equals negative 3. Y equals negative 1/2. Negative 3 plus 5 squared. And what happens is, because I did negative 3 and 5, that gave me an even number, 2. 2 squared is 4. And negative 1/2 times 4 is negative 2. So when I plugged in negative 3, I got negative 2. That's nice. Negative 3, negative 2 is right here. Negative 3, negative 2, that's 2 away, which takes me to negative 5, negative 2. Here's my shape with arrows. You must have arrows. And those are my 3 vertex forms. So if you're only being assessed on standard form and vertex, you can stop. But if you are going to be assessed on x-intercepts, then please hang out. So first thing is this is x-intercept form, and that template is y equals a times the quantity x plus p, x plus q, where p and q, the opposite of p and the opposite of q, no, that's not really. You have to solve. You can't do the shortcut. That'll be interesting. I'm going to tell you not to do the shortcut. You can't make the assumption because sometimes x is going to have a coefficient. But we'll go into how we get intercepts. So in this case, our first thing is find the x-intercepts. We know that x-intercept y equals 0. So if we substitute 0 in for y, we get x minus 3, x plus 2. And what we're going to utilize here is the 0 property of multiplication. We know that one of these boxes, these invisible boxes, either this value has to simplify to 0 or this value has to simplify to 0. That's the only way you can get 0 as a product of 2 numbers. So the question you ask yourself is, what value for x would make this 0? And what value for x in this box would make it equal to 0? So we would just solve that. And we know that when x is 3, that would be 0. And we would subtract 2, and we get x equals negative 2. So these are my 2 x-intercepts, because this happened when I plugged in 0 for y. So my x-intercept, where the parabola crosses the x-axis, is at 3 and negative 2. Ooh, did I pick a tough first one? That's not nice, Mr. Mack. You shouldn't giggle. That was an evil giggle he just did. Yes. So if they're going to be reflecting of each other, we know that the axis of symmetry is going to be midway between these 2 points. So what we can do to find the axis of symmetry is we find the distance between those 2 points. The distance is 5 and divide by 2, which is 2.5. So I know that my axis of symmetry is going to be 2.5 in. So that's 1, 2.5, and 1, 2.5. So I know that the axis of symmetry is going to lie right here. at 1/2. So the mathematical way is axis of symmetry, find the distance between the intercepts, the x-intercepts, which is 5 in this case, and take half. So half of 5 is 2.5. Okay, so that doesn't tell me what my formula for my axis of symmetry, that just tells me the distance I'm going. And if we look, we see that 2.5 in from one of those intercepts would take me at x equals 1/2. This is the axis of symmetry. And this is important not only so we can graph it, but also for what our next point is, or our next step is find the vertex. So we need to be able to find the axis of symmetry and have an equation so we know what x value to plug in. So if my equation is y equals x minus 3x plus 2, x minus 3x plus 2, how lovely is that? We're going to plug in 1/2 for x. 1/2 for x. We get negative 2.5 and we get positive 2.5. Now I can't multiply those, so I'm going to convert them to fractions, improper fractions, shall we call them. And now I'm going to multiply. Negative 5 times 5 gives me negative 25. 2 times 2 is 4, and that gives me negative 6 1/4. So this is my vertex. How fun is this vertex? 1/2, negative 6 1/4. That is one ugly bird. So 1/2, negative 6 1/4 takes us right here. 1/2, negative 6 1/4. Everybody's going to need to have that point. Now here's the nice thing. Here's the nice thing is finding the y-intercept. I need you to find the y-intercept. So when we're in intercept form, I need the vertex, I need 2 or 1 x-intercept, and I need the y-intercept. So to find the y-intercept, I'm going to plug in 0 for x. So that formula again was y equals x minus 3x plus 2. So let's plug in 0. 0 minus 3, 0 plus 2. Y equals negative 3 times 2. Y equals 6. So my y-intercept is going to be 0, negative 6. Is my y-intercept. Let's go to the graph. 0, negative 6 is nice and easy. That's a good one. 0, negative 6. It's a half away, so I go a half the other way, and that takes me to 1, negative 6. I have 5 points, and I'm done. So x-intercepts are fun and easy because I'm able to find 2 points relatively quickly. Those are the intercepts. I'm getting a drink. I don't think I've ever had that noise on my video before. So looking at it, I can immediately see that my x-intercepts are going to be negative 7 and negative 3. So negative 7, negative 3 are right there. What's the distance between those points? 1, 2, 3, 4. So I take half of 4, which is 2. So I'm going to go into, and I'm going to go into, and that takes me to there. So I'm able to find my axis of symmetry. Distance is 4. divided by 2 is 2. That doesn't tell me what my axis of symmetry, that just tells me the distance to my axis of symmetry. If I had to write an equation for that, that x crosses at x equals -5. And again, I need to know that value because I got to find my vertex. And my vertex is going to have that x value. Now we're going to plug in -5. I should also notice that my a is -1, so it's going to be upside down. So when I plug in -5 for x, I have -5 plus 7 and -5 plus 3. So -5 plus 7 is 2. -5 plus 3 is -2. 2 times -2 is -4. And then the opposite of -4 is 4. So when I plugged in -5, I got +4. This is my vertex, which is going to be -5, 4, which is going to be a max. -5, 4, a max point. Now I need to find, I'm not picking just any random point. Typically the fourth is pick an x value, but I don't have my y-intercept yet. So I need to find my y-intercept. That's going to be important. You need to remember that you still have to find the y-intercept by plugging in 0. So we get the opposite of 0. I think it's plus 7 and 0 plus 3. Is that correct? Plus 7 plus 3, yes. So that gives me -7 times 3, or -21. So 0, -21 is my y-intercept. Not a fun point to graph because it's way down here again. 0, -21, that is 5 away. So I'm going to go 5 in the other direction, which takes me to -10, -21. And I have 5 values. So those should be, we all should have the same 5 values for x-intercept. We all should have the same 5 values for x-intercept for 7, meaning all 5 values should be the same. All 5 values should be the same. This one, we're going to get a little bit different. So we see this, and we might want to, don't mistake this. You could mistake this. You could mistake this for vertex form, couldn't you? But we're going to do this as x-intercept. I just saw that. That's very, oh, and yeah, that's a very unique one. So this is really x plus 1 times x plus 1. So my x-intercepts is -1. They're both -1, but we don't do it twice because there's only one -1. So in this case, it's going to bounce off of it. It's going to bounce off the x-axis, the bottom of my parabola. So that's a bummer, but it's also pretty good because if it bounces off of it, then that's my vertex. So my x-intercept is not only my axis of symmetry. Axis of symmetry is x equals -1. And my vertex, my x-intercept is my vertex. And that location is -1, -1, 0. That's why it's my x-intercept, it's my vertex. I plugged in -1 and I got 0 times 2, which is 0. So here's where we're at step 4 and we still only have 1 point. So let's find the y-intercept. That one will be good. X equals 0. So we get y equals 2 times 0 plus 1. We can do quantity squared, the original equation. No need to write it out twice. We're going to simplify inside the parentheses. And then we're going to do the exponent. And then we're going to multiply by 2. So when we plugged in 0, we got 2. 0, 2. We can mirror that one over, which takes us to negative 2, 2. We got 3 points. Now this is where we should have these same 3 points, and our fourth and fifth may be different. I'm going to plug in 1 because I'm going to make it easy. You may choose some other number, which is fine. I'm going to plug in x equals 1 into the equation y equals 2 times 1 plus 1 quantity squared. So we get y equals 2 times 2 squared. 2 squared is 4. 2 times 4 is 8. So when I plugged in 1, I got 8. 1, 8 is right there. It's 2 away. That's going to take me to negative 3, 8. And I have 5 points. And we are done. Woo, baby! How cool and fun was that? So 3 of these values should all be identical to mine, and then depending on what you picked as your fourth x value will determine that. Hope this worked. Have a good one. I'll see you tomorrow. If you have questions, come and see me.